Let's freedom for in calculus. How can we use it? Uh, the top must be written in this form: x raised to the power of n minus a to the power of n. So we must have negative between them, and the power must be the same as the power. N and n here, they are the same. So we have negative in between them, and the power must be like the power n and n. And we have down here negative also, okay? And the power must be like the power. So we will divide the power by the power. The power here is n and the power here is 1. So n divided by 1. After that, you write the value after the negative, which is a. Then you will subtract powers, n minus 1. Like what? Like if I have x to the power of 5 minus 2 to the power of 5, all divided by x minus 2. We will divide the power here by the power. The power here is 5 at the top. So write 5, the power at the top, divided by the power at the bottom. So 1. So 1 here. And then you write the number after the negative, which is 2. Then you will subtract powers, 5 minus 1. That's it. Here we have x to the power of m minus a to the power of m. So we have negative in between them. And the power here is the same as the power here. So it's m and m. And down we have x minus a, and the power here is the same as this power here, n. So what is the law? You will divide the power by the power m divided by n. So power divided by power. The power at the top divided by the power at the bottom. Then you will take the number after the negative, which is a. Then you will subtract powers, m, the power minus the power. So it will be n over m multiplied by a, the number after the negative, then m minus n. Here we have x cubed minus 8, all divided by x minus 2. So we'll write it as x to the power of 3 minus, we can write this 8 as 2 to the power of 3, all divided by x minus 2 when x approaches 2. So you'll divide the power by the power. The power here is 3 and the power here is 1 at the bottom. So it's 3 over 1. Then you write the number after the negative, which is 2. Then subtract powers, 3 minus 2. So it will be 3 multiplied by 2. And 3 minus 2 is 1. 3 times 2 equals 6. Look at this example. I want to find the limit when x tends to negative half. So we have 32x to the power of 5. We can write it as 2x all raised to the power of 5. All raised to the power of 5. But we have a problem here. We have 1. But we can just write this plus here as negative, okay, multiplied by negative 1 to the power of 5. What is that? You know that negative 1 to the power of 5 is negative 1. And if we put negative in front of this negative 1 to the power of 5, it will be negative times negative 1, which is 1. So just I rewrite it as negative, okay, because this negative is a must to use the law. And I wrote 1 here as negative 1 to the power of 5. I didn't change any of the values at the top. And down here, you write 64x to the power of 6. We can write it as 2x all raised to the power of 6. Because 2x to the power of 6 is 64x to the power of 6 minus. This minus is a must, okay? And right here, minus 1 to the power of 6. And you know, minus 1, negative 1 to the power of 6 is the same as 1, okay? And I put negative here, just to balance it, to make it the same. And if we looked at the limit, x tends to negative half. If we multiplied both sides by 2 here, multiply by 2 and multiply here by 2, you will find 2x tends to negative 1. And if we looked at the limit again, we have here 2x at the first, and we have minus 1 secondly. And down we have 2x, okay? And here we have minus 1. So we can apply the rule, which is divide the power by the power. It's 5 over 6. Then take the number after the negative, which is negative 1. Then subtract powers here. You write 5 minus 6. So it's 5 over 6 multiplied by negative 1, okay, to the power of negative 1. So it's 5 over 6. We can move it down. It will be 1 over negative 1 to the power of 1. We ended up with negative 5 over 6. Here in this example, we have a limit, and this limit x tends to 4. So the limit must be written as x at the very beginning, and we have negative, and the second term must be 4. Okay, so x raised to any power, I don't care about the power, but this must be 4. And if we looked at 128, this 28 is 4 raised to the power of 7 over 2. How is that? You know, 4 raised to the power of 7 over 2. We can write this 4 as 2 to the power of 2, all raised to the power of 7 over 2. We have 2 powers, so multiply them, it's 2. And 2 times 7 over 2, it's 2 to the power of 7, which is 128. So we'll write it as x raised to the power of 7 over 2 minus this 28. 128 is the same as what? It's the same as 4 to the power of 7 over 2. So we will replace it with 4 to the power of 7 over 2. All divided by this x here to the power of 5 over 2. This is the power. And 32, you know, 32 is the same as 4 to the power of 5 over 2. Let's analyze it. This 4 is 2 to the power of 2, all raised to the power of 5 over 2. And if you checked it, it will be 2, and then multiply powers. 2 times 5 over 2, it's 2 to the power of 5, which is 32. So we're going to replace the 32 by 4 to the power of 5 over 2. Now we can apply the rule. Because we have here 7 over 2 and have here 7 over 2, and we have negative between them, and we have down the power is the same as the power, and we have negative between them. So you will divide 7 over 2 divided by 5 over 2. The power divided by the power. Then you will take the number after the negative, which is 4. And subtract powers. It will be 7 over 2 minus 5 over 2. Okay. You can use the calculator to find it quickly. It is going to be 28 over 5. This one here is the square root of x to the power of 3 minus 8 over x squared minus 16, and x tends to 4. You know, x tends to 4, so the first term must be x, and we have negative, and we have 4 the second term. So square root of x to the power of 3, it's the same as x, and divide this power here 3 by the index of the root. It will be x to the power of 3 over 2 minus 8. You know, this 8 can be written as 4 to the power of 3 over 2. You know, 4 to the power of 3 over 2 is the same as, we can write this 4 as 2 to the power of 2, all raised to the power of 3 over 2. Multiplying the powers leads to get 2 to the power of 3, which is 8. So replace this 8 with 4 and raise it to the power of 3 over 2, like this power here. It's 8 also. All divided by x squared minus this 16 can be written as 4 to the power of 2. Now we are able to apply the rule. Do you know why? Firstly, we have negative between them. And the top is the same as the bottom. We have here x minus 4. This is the top, the basis of the top, and we have here x minus 4. And the power here, the power is 3 over 2, and the power here 3 over 2. And the power at the bottom is 2, and the power is 2. So what is the rule? You will divide the power by the power. 3 over 2 divided by 2. Then write the number after the negative, which is 4, multiplied by 4. Then subtract powers. 3 over 2 minus 2. Okay. Don't panic and use the calculator to find the value. By using the calculator, the value is going to be 3 over 8. It's going to be 3 over 8. That's it. You should be familiar with roots, and I have here the fourth root of x power of 7. You know that this is going to be written as x to the power of, divide this power 7 by the index, root 7 over 4. And if you checked 128, this 128 can be written as 16 to the power of 7 over 4. Let's check it. This 16 is the same as 2 to the power of 4, all raised to the power of 7 over 4. Multiply the two powers. It will be 2 to the power of 4 times 7 over 4. It's 2 to the power of 7, which is 128. So replace 128 with 16 to the power of 7 over 4 divided by x minus 16. Then divide the power by the power. The power here is 1 at the bottom. So it's 7 over 4 divided by 1 multiplied by, take the number after the negative, which is 16. Then subtract powers. 7 over 4 minus 1. So by using the calculator, it will be 14. It will be 14. So it's, if you want to just don't use the calculator, so it's 7 over 4, it's 16, and 7 over 4 minus 4 over 4, it's 3 over 4. Okay. So it's 7 over 4 times 16, it's 2 to the power of 4, all raised to the power of 3 over 4. So it will be 7 over 4 multiplied by 2 to the power of 3, which is 8. So 8 divided by 4, 2 times 7, it's 14. Let's go to the next one. We have here x power of 17 minus 1. So leave the top as it and factorize the denominator. The denominator can be factorized. We write 3x here. Okay. Multiplied by x, 3x times x, 3x squared. We have at the middle, the middle term is 2x. So you're going to write here plus 5 here and minus 1. And check it, you will get the same expression here. If you multiply them, you will get the same expression here. And write at the top as it, it's x to the power of 17 minus 1. You know this one can be written as 1 to the power of 17. Then we can split the denominator here as two limits. So it's limit of 1 over 3x plus 5 multiplied by the limit of x to the power of 17 minus 1 to the power of 17 over x minus 1. Here in the first limit, x approaches 1. So it's a direct substitution, but instead of x1, it will be 1 over 3 times 1 plus 5. So 1 over 8 multiplied by, here we are going to use the theorem, which is 17 over 1 and write the number after the negative. It's 1 multiplied by 17 minus the power here is 1, so 1 to the power of 16. So that is going to be 1 over 8 multiplied by 17 over 1, which is 17, and 1 to the power of 16, it's 1. So we ended up with 17 over 8. Let's have a look at this one. We have x minus 5 between two brackets, all raised to the power of 7. But when we went down, we have here x minus 6. We can split this minus 6 here into negative 5 and negative 1. So that is going to be written as x minus 5 as it to the power of 7 minus 1. We can write it as to the power of 7, all divided by x minus 6. Write it as x minus 5, then minus 1. When x tends to 6, but we can just write this limit, x approaches 6. Instead of that, if we put minus 5 in the both sides here, in both sides, minus 5 and minus 5, you will get x minus 5 here tends to 6 minus 5, which is 1. Now we can apply the rule. Divide the power by the power. So it's 7 divided by 1, because the power here is 1 and the power here is 1. And take the number after the negative, which is 1, then subtract powers. 7 minus 1, 6. So it's 7 times 1 to the power of 6, which is 1. So that is going to be 7. If we look at this limit here, we have x plus 2 all raised to the power of 5 minus 32. So it's x plus 2 to the power of 5 as it. We can just write 32 as 2 to the power of 5. What about this x here? We can just add 2 and subtract 2. When adding 2 and subtracting 2, there is no something happened. I didn't change the value of the denominator. So right here as x plus 2, then minus 2. Just I did it to apply the rule. Now we have x tends to 0. If we put 2 here to both sides, so x plus 2 tends to 2. Okay. Then apply the rule. It's 5 divided by 1. The power divided by the power. Take the number after the negative, then subtract powers. 5 minus 1 is 4. So it will be 5 times 2 to the power of 4 is 16. 5 times 16 is 80. I think we have a problem here. Do you know? We have here 2, negative 2. The coefficient of x is negative 2 here, and the coefficient of x here is 5. And I see it's a hard mission to expand 1 minus 2 to the power of 5. So we are going to leave it as it. It's 1 minus 2x all raised to the power of 5 minus 1 to the power of 5. But here we have a problem. The problem is having 5 in front of this x. How can we make this 5 as negative 2? I want to write this 5 as negative 2. So we can write it as negative 2 if we multiplied it by negative 2 over 5. Once you have multiplied the bottom by a number, so multiply the top by the same number. So we are going to multiply it by negative 2 over 5. So I multiplied by negative 2 over 5 up and down. And why I did it? Just to cancel this 5 and this 5. Okay? What I multiplied by in the denominator, I multiplied by in the numerator. Okay? Just to make balance between them. And why I did multiply by negative 2 over 5, just to make it negative 2x. Then you will get at the top negative 2 over 5 limit and write 1 minus 2x to the power of 5 minus 1 to the power of 5, all divided by negative 2x. Till now, we couldn't use the law, but we are going to add 1 here. We are going to write 1 here and subtract this 1 here. And I didn't change any of the values of the denominator because I added 1 to it and subtracted 1 from it. Now we can apply the rule. It will be, write the negative 2 over 5 as it. It will be the power divided by the power. The power is 5 divided by 1. Then take the value after the negative, which is 1. Then subtract powers. It will be 4. So that is going to be negative 2 over 5 multiplied by 5. And 1 to the power of 4 is 1. So we ended up with negative 2. In this limit here, we have a cubic root, and we have learned it before. How can we deal with the cubic root of something? It will be 1 plus 3x, then divide here, divide the power here is 1. It's not written, but it's 1. Divide it by the index root. So I have here 1 plus 3x under the cubic root is going to be 1 plus 3x all raised to the power of 1 over 3 minus 1. All divided by 2x. We faced this problem in the previous example. The problem here is having 3x, the coefficient of x is 3, and the coefficient of x here is 2. And also we have learned how can we make this coefficient at the bottom as 3. If we multiplied it by 3 over 2, it will be 3. And because I multiplied the bottom by 3 over 2, so multiply the top by 3 over 2 to make a balance between them. So write 3 over 2 and write limit. And I have here 1 plus 3x to the power of 1 over 3 minus 1. We can write this one as 1 over 3, all divided by, cancel 2 and 2. It's 3x here. Then the same idea. I wanna apply the rule. I wanna apply the law. So we have 1 here and minus 1 here. So we can write here 1 plus 3x and subtract this 1 here. I didn't change the value. Okay, the value is the same value because I added 1 to it and subtracted 1 from it. Now we can apply the rule. It will be 3 over 2. Then you will divide the power by the power. It's 1 over 3 divided by 1. Then take the number after the negative, which is 1. Then subtract powers. It will be 1 over 3, the power at the top minus the power at the bottom, which is 1. So it's 3 over 2 multiplied by 1 over 3. And 1 raised to any power, it's the same as 1. So cancel, 3 cancel, this 3, 1 cancel another out, so we ended up with half. When it comes to the limit, x tends to 0. If we multiplied here by 3, because x tends to 0, something like the equation, we can multiply by 3 here and multiply by 3 here. So 3x tends to 0. 0 multiplied by 3 is 0. And add 1 here, plus 1 here. So add 1 here at this side. So 1 plus 3x tends to 1. So this limit equals half. Here x approaches to negative 1. And what is the idea here? We can write it as x to the power of 7, then split this 2 into 1 plus 1 as a team, plus x to the power of 9 plus 1. What happened? I split this 2 into 1 and 1. Here's 1 and 1, all divided by x plus 1. So this denominator is for all the top. It's for all the numerators. So we can write it as x to the power of 7 plus 1 divided by x plus 1 here, plus x to the power of 9 plus 1 all divided by x plus 1. We couldn't apply the law here. Do you know why? Because we have plus here and plus here, plus and plus. We must make it negative. So we are going to write it as x to the power of 7 minus 1 to the power of 7. And minus 1 to the power of 7, it's minus 1. And we have negative here. So negative multiplied by negative 1 to the power of 7 is going to be negative times negative 1, which is 1. So I didn't change the value of the numerator. All divided by x minus 1. It's the same because we have here 1 and negative times negative is 1. Plus, we will do the same here. It's x to the power of 9 minus 1 to the power of 9 divided by x minus 1. Then apply the law. We have two limits here. Divide the power by the power. So 7 divided by 1. Take the number after the negative, which is negative 1. Then subtract powers. It's 6. Plus, do the same here. It's 9. The power divided by the power is 1. Then take the number after the negative, which is negative 1. Subtracting powers, it's 8. So 7 multiplied by negative 1 to the power of 6, it's 7. 7 plus 9 equals what? 16. Now let's go to the limit of the function at infinity. And let's have a look at this function here. F of x is 2x plus 1 divided by x. X approaches to infinity. So here, if we wrote instead of x infinity, so it will be 2 times infinity plus 1 all divided by infinity, and 2 times infinity plus 1, it's infinity all at the down here, at the bottom here we have infinity, and infinity over infinity. From the first session we know that infinity over infinity is an unspecified quantity. I want to get the value of this function when x tends to infinity. So we can take a value, just a big value, like 1 million, 1 milliard, and put it in this function. And use the calculator. So let's do it now. this one here, the limit of x cubed minus 5x plus 3 as x tends to infinity. If we put instead of x infinity, so it's infinity to the power of 3 minus 5 multiplied by infinity plus 3. So you will end up with infinity minus 5 times infinity. It will be minus infinity plus 3. But we know that infinity minus infinity is unspecified quantity. So we need a way to find this limit. We can take x to the power of 3 as a factor here. If we took x to the power of 3 as a factor, then dividing this term by x to the power of 3 leads to get 1. And minus 5x divided by x to the power of 3, it will be minus 5 over x squared here. And here 3 divided by x cubed, it will be 3 over x cubed. Now we can find the value of this limit because 5 over x squared equals 0. And this one equals 0. And x to the power of 3, it's infinity to the power of 3, which is infinity. So infinity multiplied by 1 is going to be equal infinity. I want to get this limit here as x tends to infinity. So what is the idea here? The idea is to divide by the term with the highest power in the denominator. So we are going to divide by x to the power of 5 because x to the power of 5 is that term with the highest power at the denominator. So for x to the power of 5 plus 5 divided by 8x to the power of 5 plus x to the power of 4 minus 2, you will divide by x to the power of 5, all of them, divide by x to the power of 5, the top and the bottom. The term with the highest power. So for x to the power of 5 divided by x to the power of 5 equals 4 plus, and 5 over x to the power of 5, x tends to infinity, so it's 0, divided by 8x to the power of 5 divided by x to the power of 5 equals 8, then plus here. X to the power of 4 divided by x to the power of 5, it will be 1 over x, and here minus 2 over x to the power of 5. And 1 over x equals 0, and negative 2 over x to the power of 5 equals 0. So it will be 4 over 8, which is half. The limit of this function as x tends to infinity. So we have 5x to the power of negative 3. We can write it as 5 over x to the power of 3 plus. We have 4x to the power of negative 2. We can write it as 4 over x to the power of 2 minus 3 divided by. At the bottom, we have here 7x to the power of negative 3. We can write it as 7 over x to the power of 3 minus 2x to the power of negative 2. It's 2 over x to the power of 2, then plus 8. This one here equals 0, and this one equals 0, and here 0, and here 0. So it will be negative 3 at the top, and at the bottom it's 8, negative 3 over 8. I want to get the limit of 5 plus x minus x squared. If we substituted x equals positive infinity, so it will be 5 plus infinity minus infinity to the power of 2, which is 5 plus infinity minus infinity. And this value is unspecified value. So we can deal with it by taking x to the power of 2 as a factor. So 5 divided by x to the power of 2, it will be 5 divided by x to the power of 2. And this one here, it will be plus, okay, 1 over x, divide x by x to the power of 2, it will be 1 over x, minus 1 here. You know, 5 over x squared equals 0. and 1 over x equals 0, and we have here minus 1. And x to the power of 2, it's positive infinity to the power of 2, which is positive infinity, multiplied by 0 plus 0 minus 1, multiplied by negative 1, which is negative infinity. How can we get this limit here? What is the term with the highest power in the denominator? If you expand x plus 1 multiplied by 2x squared minus 3, you will get a term with the power raised to the power of 3, with the power of 3. So the highest power at the bottom is x to the power of 3. And I want to tell you an important information. If we have something like 5, okay, divided by 3 times 4. You know, this one here is 5. We can write it as 5 over 3 times 1 over 4. Don't write this 5 again. But if we have here something like, pay attention, let's say 3 plus 4 divided by 5. You know, in this case, this denominator here belongs to 3 and belongs to 4. So we can write it as 3 over 5 plus 4 over 5. Okay. If we have 3 times 4, all divided by 5, we can write it as 3 over 5 times 4 only. Okay. That's what I want to say. So when dividing here by x to the power of 3, when dividing here by x to the power of 3, this power of 3 here, we can split it into x to the power of 2 and x. We can split it into x here and here x to the power of 2. That's what I want to say. So I divided by x to the power of 3. And if we look well, you will get here, yes, I divided by x to the power of 3. And I have here x plus 1 all divided by x. You know, this x here belongs to this x and belongs to this 1. So we can write this x here as x over x plus 1 over x, because it's adding. And here x to the power of 2 belongs to this numerator and this numerator. So we can write it as x to the power of 2 here minus 3 over x to the power of 2 here. So what I did, I divided the top and the bottom by x to the power of 3. So it will be 8x to the power of 3 minus x plus 1 divided by x to the power of 3 divided by x to the power of 3 divided by x to the power of 3 divided by. Here it's x over x plus 1 over x multiplied by 2x to the power of 2 all divided by x to the power of 2 here minus 3 over x to the power of 2. So x to the power of 3 and x to the power of 3 have been cancelled. So it's 8 here minus x over x to the power of 3. It will be 1 over x to the power of 2, which is 0. And 1 over x to the power of 3, it's 0 also. So it's 8 minus 0 plus 0 divided by x divided by x, it's 1. And 1 over x, 0 plus 0 multiplied by x to the power of 2 divided by x to the power of 2, it's 2 minus 3 over x squared, it's 0. So we ended up with 8 divided by 1 times 2, it's 2. 8 divided by 2 equals 4. I want to tell you, before you tackle this question, I want to tell you an important information. You know, x is the same as the square root of x to the power of 2. Yes, that's right. The square root of x to the power of 2 is x. And also you know that x is the cubic root of x to the power of 3. Yes, that's right. Because we divide this power by the index. So we are going to divide by the highest. We are going to divide by the term with the highest power. The term with the highest power in that denominator. So what is this term? Don't say it's x to the power of 3. That's not right. Do you know why? Because this x to the power of 3 is written under the cubic root. So we are going to divide by x. We are going to divide by x, which is under the cubic root. It's x to the power of 3. And which is under the square root is x to the power of 2. So we are going to divide the numerator and the denominator by x. So let's write them. Here at the top we have under the square root 9x to the power of 2 minus 3x plus 8. Here the square root and here the cubic root. And I have here 3x to the power of 2 plus 125x to the power of 3 plus 2. We are going to divide by x, which is under the square root x to the power of 2, x to the power of 2, x to the power of 2. And under the cubic root, it's x to the power of 3. So here x to the power of 3, and here x to the power of 3, and here x to the power of 3. This one here is 0. This one is 0, and this one is 0. So it's the square root of 9, because x to the power of 3 cancelled with x to the power of 2. X to the power of 2, sorry, cancelled with x to the power of 2, all divided by the cubic root of. Here, x to the power of 2, and here x to the power of 3, so it's 0. And here 0. And x to the power of 3 and x to the power of 3 went cancel another out, so it's the cubic root of 125. The square root of 9 is 3, and the cubic root of 125 is 5. Some students get confused and say, Mister, we divided at the top by x to the power of 2, and we divided at the bottom by x to the power of 3, and that's not right, you know, because I divided by x, but this x under the square root is x to the power of 2, and this x under the cubic root is x to the power of 3. That's it. In this one here, we are going to multiply by the conjugate, the top and the bottom. So the conjugate is the same, but it changed the sign between them. Here it's a plus instead of minus. And then multiply. The square root multiplied by the square root, it will be x squared minus 2. Negative times positive, so it's a negative. And multiply x squared plus x by x squared plus x is going to be what? X squared plus x divided by the square root of x squared minus 2 plus the square root of x squared plus x equals. Here we have negative, and this negative is multiplied by this bracket. So it's x squared minus 2 minus x squared minus x divided by. Write the same denominator as it. X squared minus 2 plus square root of x squared plus x. Cancel x squared and negative x squared. So we have at the top negative 2 minus x, and we have at the bottom the square root of x to the power of 2. And I want to use the information we have learned. We are going to divide by the term with the highest power at the bottom. So we have x to the power of 2, but this x to the power of 2 is written under the square root, so it's x. We are going to divide by x, the top and the bottom. So 2 is divided by x here, and x divided by x. But at the denominator, we are going to divide by x to the power of 2. Do you know why? Because we have the square root here, x to the power of 2, and here x to the power of 2. So this one, 2 to the power of x equals 0, and negative x divided by x, it will be negative 1 here, over. Here I have the square root of x to the power of 2 divided by x to the power of 2, and this one equals 0, so the square root of 1 plus here x divided by x to the power of 2 equals 0, and the square root of 1. So it's negative 1 over 2. That's it. And what is the idea of this question here? You will multiply by the conjugate of the denominator and the numerator. So you are going to multiply by, what is the conjugate of the numerator? It's the square root of x plus 1 plus the square root of x minus 1 at the top and at the bottom. X plus 1 here and plus the square root of x minus 1. And multiply by the conjugate of the denominator, which is the square root of 4x plus 1 and here plus the square root of 4x minus 1. And at the top, it's the square root of 4x plus 1 and here plus the square root of 4x minus 1. Then multiplying them leads to get, we can multiply them easily. It's x plus 1 and minus x minus 1. It will be negative x, okay, because we have negative here. And after multiplying them, it's x minus 1 multiplying by the negative. So it's a negative x plus 1, okay, over. Here it's 4x plus 1. And multiplying the square root here by this square root, it's 4x minus 1. And we have negative in front of it. So it's negative 4x and then plus 1, okay? Cancel x and negative x. Then we have at the top 2. And here cancel this and this one. We have at the bottom 2. And then we have the square root of 4x plus 1 plus the square root of 4x minus 1 over the square root of x plus 1 plus the square root of x minus 1. Okay, x approaches to infinity. So what is the idea? 2 and 2 cancelled, okay, because multiplied, 2 is multiplied by them and this one multiplied by them. Then divide by the highest power, the term with the highest power at the denominator, which is x here and x here and x here and x here, here x and here x, here x. But under the square root, you know, we have here a square root of x. So what is the highest power in the denominator? It's x to the power of half. Do you know why is that? Because it's written under the square root. So divide by x to the power of half, which is x under the square root. So you'll end up with the square root of 4 here, 2, and here 4, 2. So 2 plus 2 is 4 divided by. Here's the square root of 1. It's 1 plus the square root of 1, which is 2. So 4 divided by 2 here equals 2.